Hey everyone, welcome back. I hope you're all doing well. In this video, we're going to learn about activity duration estimation, a crucial task of project planning and scheduling. Let's begin by reviewing the learning objectives for this lesson. By the end of this lesson, you'll be able to 1. Identify factors affecting activity duration, 2. Estimate duration using RS, means, and PERT methods, and 3. Understand the parametric estimation method. This video covers the first objective and the first part of the second objective. The rest will be covered in the next video. Now, let's go over a few key definitions. First, what is activity duration? It refers to the estimated time required to complete a specific task within a project. This estimate is a critical input for scheduling, particularly in construction projects. Accurate activity duration estimation ensures that projects are completed on time and within budget. Without reliable estimates, projects are at risk of delays, increased costs, and poor coordination. So, who estimates activity duration? Well, the task of estimating activity duration is typically handled by schedulers or project planners who work with various stakeholders, including the client, general contractor, and subcontractors. For the client, the primary goal of estimating duration is to set realistic expectations for the project's completion date. By understanding the time required for each task, they can identify key milestones and deadlines that need to be met. If the client sets unrealistic expectations, it can negatively affect the project, leading to delays and higher costs. The general contractor, on the other hand, is responsible for overseeing the entire construction process. For this reason, they need to estimate activity duration carefully in order to develop a detailed project schedule. This schedule allows them to allocate resources efficiently, manage subcontractors, and ensure that tasks are completed on time, ultimately maintaining the overall project timeline. Similarly, subcontractors who handle specialized tasks such as electrical, plumbing, or HVAC work must estimate the duration for their specific activities. These estimates help them plan their work within the broader project schedule and ensure that they coordinate effectively with other teams. When estimating activity duration, several critical factors must be considered to ensure accuracy. Location plays a crucial role. Constructing a building in a remote, difficult-to-access area may require additional time for transporting materials and equipment, leading to delays. In contrast, a project located in an urban area with easy access to suppliers and resources may be completed more quickly. Crew skill and size also significantly impact the duration of tasks. A highly skilled crew with years of experience, such as those installing HVAC systems, will likely complete tasks faster than an inexperienced team. Similarly, the size of the crew can affect the timeline. Larger crews can accelerate tasks like excavation or framing, whereas smaller crews may take more time to complete the same work. The availability and condition of equipment must also be taken into account. For example, if a crane needed to lift heavy materials for a high-rise building malfunctions or is unavailable, it can delay critical tasks such as structural framing or window installation. On the other hand, having the right tools and machinery in good condition can streamline processes and reduce the time needed to complete tasks. Finally, weather is another crucial factor that can impact activity duration. Construction projects are highly susceptible to weather disruptions. Heavy rain or snow can halt work on outdoor tasks, like road paving or foundation pouring, while extreme heat can cause delays in tasks that involve curing concrete, making the process harder to control. As such, weather introduces a level of uncertainty into the estimation of activity duration, which is why contingency planning is essential. By carefully considering these factors, location, crew skill and size, equipment availability, and weather, project planners can develop more accurate estimates of activity duration. This helps to mitigate risks and ensures smoother execution of the construction project. Now, we'll go over the methods commonly used to estimate activity duration. To estimate the duration of a task, this is a basic formula often used. Duration equals quantity divided by productivity. Quantity is relatively straightforward to determine, as it is based on design drawings. Since the quantity is already established in the plans, there is generally low uncertainty. The actual amount rarely deviates significantly from the estimate. On the other hand, productivity is much harder to estimate. It is influenced by a range of factors such as weather, work conditions, equipment performance, and the skill level of the workers involved. As a result, productivity carries high uncertainty because these variables can change frequently, making it more challenging to predict with accuracy. When it comes to gathering productivity data, there are several sources available. Company data is the most preferred source for estimating duration. The production rates from previous projects provide accurate estimates based on the company's past performance. When company data is unavailable, the RS Means book is a widely recognized industry resource that can be used. It offers productivity rates for a wide range of construction tasks, compiled from data collected across numerous projects. For example, it might specify how many cubic yards of earth can be excavated per hour using a certain piece of equipment. This helps make more informed estimates. However, it's important to note that the production rates provided are based on general conditions and may not always align with the specific circumstances of a given project. In these cases, experience plays a significant role. Experienced professionals can rely on their knowledge of how long tasks typically take under varying conditions and adjust the estimates accordingly. Now, let's apply the basic activity duration formula to a few examples. In this first example, you need to answer the question, how long would it take a crew with a productivity rate of 1,000 square feet per day to complete 5,000 square feet of slab formwork? To estimate how long it will take for the crew to complete the slab formwork, we need to find the total work that needs to be done. In this case, the total slab formwork area is 5,000 square feet. Next, we look at the crew's productivity rate. The crew can complete 1,000 square feet per day. To determine the number of days required, we divide the total work by the daily productivity rate. 5,000 square feet divided by 1,000 square feet per day equals 5 days. This means the crew will need 5 full days to complete the slab formwork under normal working conditions. However, in real-world construction, factors like weather, site conditions, and crew availability could affect the actual duration. Still, this estimate provides a solid baseline for scheduling and planning. Here's another example. A new building has a perimeter of 40 feet by 75 feet and a height of 10 feet with a brick exterior. The goal is to determine how long it will take to place all the brick. The crew has a productivity rate of 220 square feet per day, according to RS means. To estimate how long it will take to place the brick for this building, we start by calculating the total wall area. The building has a perimeter of 40 feet by 75 feet, and the walls are 10 feet tall. First, we find the total perimeter by adding all 4 sides. 40 plus 75, then multiplied by 2, gives us 230 feet. Next, we multiply this by the height of the walls, 10 feet. This gives us 2,300 square feet of brickwork. Now, we can use the crew's productivity rate to estimate the time needed. As given, the crew can place 220 square feet of brick per day. To find out how many days are needed, we divide 2,300 square feet by 220 square feet per day, gives us about 10.5 days. Since construction projects need to account for delays, weather, and unexpected issues, it's reasonable to round up. So we estimate the total time needed to place the brick at approximately 11 days. Let's go through another example. Example 3. A new building has a perimeter of 40 feet by 75 feet, with a 6-inch thick concrete on-grade slab designed for 3,500 psi strength. Using the provided table, we need to estimate how long it will take to pour the concrete slab. To begin, we first need to determine the production rate using the RS means table. To do this, locate the row that corresponds to concrete on-grade slabs with 3,500 psi strength. You will notice there are 2 slab options listed, so be sure to select the one that specifies a 6-inch thickness. Next, check the corresponding columns, which display the estimated daily output productivity rate and unit of work. From the table, we find that the production rate is 92 cubic yards per day. Now that we have the production rate, we need to calculate the total volume of concrete required. Since the slab is 6 inches thick, we convert inches to feet. 6 inches equals 0.5 feet. Using the volume formula, volume equals length times width times thickness. Multiplying 40 feet by 75 feet by 0.5 feet, we get 1,500 cubic feet of concrete. Since concrete is typically measured in cubic yards, we convert this by dividing by 27, since 1 cubic yard equals 27 cubic feet. 1,500 cubic feet divided by 27 equals 55.6 cubic yards of concrete needed. Finally, we calculate the required time by dividing 55.6 cubic yards by the production rate of 92 cubic yards per day equals approximately 0.6 days. This means the crew can complete the pour in less than 1 full workday. Of course, real-world factors like weather conditions, crew efficiency, and equipment availability could slightly impact the actual time needed. However, based on this estimation, the concrete slab should be poured within a single day. Alright, that's it for this video, where we covered key concepts related to activity duration and the basic method for estimating activity duration. Thanks for watching, and we'll see you in the next video. Goodbye!